And those who are streaming online will be given an opportunity at the end of the session to ask questions, both for those people in the room and online. So I'd like to introduce Claudia Santori from Ocean Watch Australia to present Post-Bushfire Mangrove Recovery community-led efforts in the New South Wales South Coast. Welcome.
All right. Thanks everyone for having me today. I'm going to try not to move. I am a walker and I've just realized that I'm stuck here. So I apologize. Let me know if you can't hear me well. Thanks again for having me. I'd like to start by acknowledging the traditional owners of the land we're meeting on today, the Gadigal people and their elders, past, present, and emerging, and also the traditional owners of all the sites where we worked on our project on Post-Bushfire Mangrove Recovery. So my name is Claudia. I'm a project officer at Ocean Watch Australia. And I'll tell you today a bit about mangroves, why should we care for them, and about our journey in the New South Wales South Coast in the discovery of the damage that bushfires had on mangroves and how we played a little bit of a part in helping them recover. So first of all, I'm sure most of you are already aware of this, so just wanted to bring everybody on the same page. So mangroves are plants that live in the intertidal zone, so they thrive between the high tide mark and the low tide mark, so they are inundated at high tide and exposed at low tide. In Australia, we have 41 species, all with serious adaptation to the harsh environment that saltwater is. For example, many mangroves are adapted to live in saltwater by having salt excreting glands on their leaves, so they get rid of salt that way. They also live in airless soils, so a lot of them might have pneumatophores, so the pencil roots that help them breathe. They also live in soggy soils, so many mangroves will have these prop roots to help them stabilize in those conditions. And finally, they live along our estuaries and our coastal waters, and therefore they use that to their advantage to propagate. So it's not uncommon to see a lot of propagules floating around, particularly during summertime in New South Wales, and that's how they get to new places and reproduce. In New South Wales, we have 133 estuaries, and almost 70 of them have mangroves. We have 6 species. Most of them occur in the northern side of the state. In the South Coast, we only have 2 species of mangroves. So we have the grey mangroves and the river mangroves. So why should we care for mangroves? So they're extremely important for habitat and food provision for a lot of wildlife species, from bats to reptiles to crustaceans and fish. And speaking of fish, they're really important for our recreational and commercial fisheries as they provide key nursery habitats for baby fish. They also provide coastal protection, so they're a natural barrier against wave action. And therefore, they also help with erosion control. Really important for nutrients uptake, fixation, and turnover. And finally, we've talked a lot already about climate change. They're a bit of a climate change hero in that they store carbon at a faster rate, so they uptake carbon at a faster rate and they store more carbon than most other forests in the world. However, many threats are there for mangroves as well. Unfortunately, land use change is a pretty big one globally and historically also in Australia. All of that coastal development is really threatening to mangroves. Also sediments and chemical runoff is a big one for them. And finally, climate change again, with sea level change and extreme weather events. Particularly, I don't know if you saw a few weeks ago, there was a new publication on what happened in the Northern Territory with 76 kilometers square of mangroves were wiped out because of extreme El Nino conditions. So the 2019-2020 were particularly devastating bushfires. And unfortunately, we're also on a trajectory of seeing these types of events More and more in the future, we've had an increase of 800% in burnt area since the late 80s, and it's consistent with ever more dangerous fire weather conditions. In the Black Summer bushfires, about half of the UK land area was burnt in Australia, 5.5 hectares just in New South Wales. And between 1 and 3 billion animals were estimated to have been killed or displaced. The intertidal is not usually an environment that is linked to bushfire impacts. As I mentioned earlier, it's inundated for half of the time, there's high moisture, so it's generally not one that we would link to bushfire consequences. However, in the Black Summer bushfire, in some areas up to 32% of mangroves burned in some estuaries. And it's something that had never really been recorded before at this scale. And without quick 5 to 6 years recovery, there is a significant risk in losing suitable habitat for mangrove recolonization. Mangroves, as I mentioned, they're really important in holding those soils together, and with their death and when they're rotting away, all of that sediment might be released. And so we might even start seeing erosion issues and increases in turbidity, which aren't good for all our filter feeders and wildlife in the water, as well as any water activities such as aquaculture. And finally, there is loss of wildlife habitat and food resources when you lose such big parts of the intertidal vegetation. We also observed very little recovery in the summer after the Black Summer bushfires, which was really quite alarming. So how did our project start? Well, we called it community-led efforts because community was really present and driving this since day one. In fact, since day zero, as we didn't even know about this until local oyster farmers and landowners sounded the alarm to us. They responded to a survey that we put out after the Black Summer bushfires to learn about the impacts of bushfires to marine environments. And in 3 locations in the South Coast, so the Clyde River, Mogandura Creek, which is an branch of the Moruya River, and in Wonboyn Lake, community members and oyster farmers reported to us burnt mangroves, and we couldn't believe it. So we went down and saw it with our own eyes and decided, okay, let's build a project together. We were lucky enough to get the Landcare-led Bushfire Recovery grant mid last year, and so we put together this project that had these aims. So first of all, we wanted to build capacity locally to repair this intertidal habitat post-bushfire. We also wanted to collect baseline data on mangroves and the bushfire recovery, the damage, and how they were recovering naturally. We also wanted to collect data on the impact of the bushfires and to the mangroves and the consequences that had to the mangrove-related wildlife and the crabs in particular. And finally, we wanted to assist recovery where necessary, so after an assessment of how the natural recovery was doing, to speed up the natural process and avoid those issues that I mentioned earlier with the erosion, for example. So these are the sites that we worked on. Firstly, we have Batemans Bay, Batemans Marine Park. This is the estuary of the Clyde River. An amazing and beautiful place, which was unfortunately devastated by the Black Summer bushfires. You can see in the background the eucalyptus forest, which is recovering pretty well. This is a photo a year after the bushfires, but you can still notice it was, a massive, severe burn, crown burn. So everything there was affected, all the way down to the grey mangroves in the foreshore. So that's just one of many areas that essentially still look like that. Mostly grey mangroves, and you can see in the photo on the left that there's some oyster leases, so the oyster farming is really, really close to the mangroves, and that is why the oyster farmers were really quite concerned about the potential for erosion affecting their businesses. This is Mogandura farm. It's along the Mogandura Creek. It's a little part of it called Stingray Bay, mostly river mangroves, which were also pretty much 100% burnt or affected by the heat. So some of these trees actually didn't burn physically, but they cooked essentially because of the temperatures. There are some survivors in the background. You might see some green, but in the area, which is fairly small, it's about 0.6 hectares, there was pretty much nothing left. And further south, near Wonboyn Lake, there's this little part of it called Meridal Cove. You can see the dead tea trees in the background, and in the foreshore, grey mangroves. There's one survivor in the back. You can see the little bit of green that's holding on, but apart from that, everything else was gone when we arrived. So for this project, we employed lots of different methodologies, which was really fun for us because we learned a lot along the way, and also fun for the volunteers that got involved. The common denominator is that everything was very muddy and really fun that way. So first of all, we mapped mangroves with the aerial drone that we've got, just so that we could have that baseline imagery to compare to future imageries to see hopefully our success, but in any case, how the situation is progressing. We also had crab cams, so these are just camera traps that were pointed downwards to monitor the crab activities in burnt and unburnt areas in the Clyde. And then we collaborated with Mangrove Watch, which is another NGO, and they specialize in citizen science training methods for mangrove monitoring. So it was really fun to have that collaboration going and learn and train citizen scientists to mainly carry out photo points, so photos in the same location over time to measure change. Shoreline video assessment, fairly similar, but as a video and from a boat, so you can cover more ground. And then the long plots. So in this case, we can calculate biomass lost and CO2 emitted by the fires in these mangrove areas. So this is an example of the aerial footage that we got. So we only have a DJI Air 2, so it's only $1,500, so fairly accessible, fairly easy to use with a bit of practice. And the imagery that you can get is absolutely stunning. So we used an app to plan the mission, and then the drone kind of did it all by itself. And the quality is really quite incredible. So this is just a zoomed in version of the same picture. And you can see individual trees, and this is a flight to about, I think, 35 or 40 meters of height. So if you were flying lower, you could get probably even more resolution. This gives you an idea of the utility of these kinds of systems, because we could go back, this year, next year, and do the exact same mission, and then compare and see is the tree still there, has it rotted and floated away? As just the farmers keep on saying, even now, a few years in the bushfires, still trees coming down, and so this we could even say, okay, are these mangroves, some of these trees that are floating downstream. For the crab cams, so this is one of them. You can see it's just pointing down, and we're looking for these little guys. We had about 4 species of crabs in the areas, and at the bottom right is a view from the camera. We did a few videos and counted. So this is just a crossing to not double count a crab. We counted how many crabs there were, how many species, and also how many pneumatophores, so those pencil-like roots, to have an idea of the degradation of the environment, comparing burnt sites to unburnt sites. And these are some of our results. We only had 3 sites of burnt and 3 sites of unburnt, so it's a little bit of a preliminary assessment. However, in the top box plot, we've got number of pneumatophores on the vertical y-axis, and then we've got the burnt and unburnt data. And you can see it's probably not too surprising that we've got a lot more pneumatophores in the unburnt sites compared to burnt sites, because those burnt sites are starting to degrade and all those pneumatophores are rotting away. So we've got that captured there. And it's, again, not particularly surprising that that's the case, unfortunately. We also found equal diversity between sites, but we found a lot more crabs in the unburnt sites. So in the bottom box plot, we've got number of crabs on the vertical y-axis, and then again, burnt and unburnt sites. And you can see in the unburnt site, we have a lot more crabs. So what does that mean? Maybe burnt sites are not a good habitat for them anymore. And again, it's quite intuitive, there's no more leaves there. There's probably not that many food resources for them. Perhaps the mud is not as good of a habitat as it used to be. So this is, a hypothesis that would like to be tested further in the future. But, it's a good way of, it's a good starting point to see, okay, maybe we really need to do some restoration here. These are some photos from our mangrove watch activities. We've got the Wonboyn crew on the right and the Clyde crew on the left. And so this is where we laid down the long plot tape and then essentially measured all the trees that were 2 meters either side of this plot. And we did the Wonboyn at the end of last year and the Clyde at the beginning of this year. Would have preferred to do them earlier, but with COVID and all the lockdowns, so this is the earliest we could get out. And it was really interesting because we did only a few plots, and so this is just an estimation, but we were able to put together all the numbers and calculate that about 85 tons of carbon were stored above ground in the Wonboyn patch that got burned, and therefore we've lost that. And in the Clyde, an estimated 24 hectares were burnt, and so we're looking at over 7,000 tons of carbon. That might not mean much to anyone. It didn't mean much to me when I first calculated it, so I just did a bit of a back of the envelope calculation, and roughly that means about 1,600 average petrol cars driving around for an entire year. So that's quite a lot of carbon lost. But also, not to forget that mangroves are not just about carbon. They have so many benefits for the local wildlife and the coastline protection, so all of that has been lost as well as the carbon. So this was really valuable because now we have a bit of a baseline data and we have trained volunteers for long-term monitoring. The project is now concluded, but they're still really keen and they're still sending us photos and they're really keen perhaps to do some more work in the future. In our long plot monitoring efforts, we counted no seedlings at all in December 2021 and then earlier this year, which suggested to us a very slow recovery. And this was particularly, I gotta stop. Okay, I'll wrap this up. We planted a bunch of seedlings. Something that was really interesting is that seedlings were growing on the oyster baskets, and so that was a low-cost mangrove nursery. So we took those and potted some and planted directly some others. 450 seedlings planted, mostly survived during the first month, and everybody got involved. Limitations, of course, is that we only had about 10 months to work on this. Restorations takes much, much longer, and especially the monitoring takes much, much longer. So I'm just putting the take-home messages and probably leaving them there because I'm gonna get kicked out. But protect your mangroves. Thanks.
Thank you, Claudia, for that great presentation. We've just got a couple of minutes before lunch for some questions. So if there's any questions from the room for Claudia or online, yep.
Claudia, I was curious to know the difference between the number that you directly seeded into the ground and the ones that you put in pots and then put into the ground. Was there a difference in recovery or survival rate of those?
Yeah, thank you. That's a good question. So all I can say is very preliminary in that. Sorry, I'm just going to wait. Okay.
Did you want to ask again?
Sorry.
That's all good.
Claudia, I was curious to know the difference between the survival rates with the seedlings that you directly planted into the ground that you collected from the oyster boxes and the ones that you then put into the seedling lot of boxes and then subsequently put in the ground. Was there a different survival rate?
Yes, so as I was starting to say, all we have is quite preliminary because we were only able to do one round of observation a month after planting them. So ideally, we would probably be going out maybe in a year's time. But look, the direct plantings seem to be a bit more successful than the potted ones. Again, not a lot of difference, but considering the logistical ease of just taking them from the oyster baskets and putting them down, we could do a lot more of that in that same time frame than potting them. In addition to that, though, is we only could grow them in pots for about a month or 2 months before putting them in the ground. In an ideal scenario, we probably would have kept them for a year. And I know a lot of other programs keep them for a lot longer. We just wanted to have a bit of an idea of, because they grow pretty much in water on the pots, on the baskets. It's kind of like an aquaponics situation. So we thought that might be a shock to put them straight into the ground, and so maybe having them in like a protected, pot outside, all that wave action might help them. But yeah, there wasn't a lot of difference. And in reality, yeah, the logistics were a lot easier to put them straight into the ground.
Great. Thank you so much, Claudia, for that presentation. For everybody else, we've got a lunch break now until 1:50, and we're meeting back at the ballroom at 1:50 for the next sessions. So see you then.